Welcome to the January 2018 meeting of the Houston.net Users Group. You're welcome to join us in person for pizza, prizes, and networking on the second Thursday of every month. Our meetings are hosted by Improving Houston in their office at 10111 Richmond Avenue, just inside the Beltway in the West Chase area of Houston. You can check us out for meeting notifications at hdnug.org, on Facebook, or on LinkedIn. Special thanks to our sponsor this month, .net Report. .net Report is a web-based, cloud-friendly reporting tool that allows your users to create their own damn reports. Check them out at .netreport.com for a free demo.
So tonight's talk is two-way web apps with SignalR. For those of you who didn't figure it out earlier, my name is J Sawyer. I am not only the president of the Houston.net User Group, I am also a senior architect with Hitachi Consulting, based here in Houston. In my career, I've done a lot of things. Spent some time at Microsoft, at the Evil Empire, but throughout it all, I've written code. And I love writing code, and I love doing cool stuff. So I came across SignalR actually at a previous gig where we were doing real-time streaming data. And this actually wound up being a pretty cool way to do it, but there's a lot more that you can do with SignalR. And to enable the real-time two-way web world using SignalR. So a quick overview of our agenda. We're going to talk about what it is. We're going to talk about SignalR for the web. We're also going to talk about SignalR for Windows apps. So a lot of times when folks talk about SignalR, and in fact when I named this presentation, right, I said the two-way web, but it also works inside of Windows apps. It'll work inside of any .NET app or web app. And then how to do tracing. This is pretty useful when you're trying to debug, targeting individual clients, how the connections work, and then server broadcast. So, lots to talk about. So we're going to try and get into the meat of it pretty quickly. But before we get there, let's talk about how SignalR works and what its architecture looks like. So, in SignalR, you have this concept of transports, right? Transports are at the lowest level. You really don't mess with them. They are pluggable, right? But there's really no need to do that. We'll talk about well, you can see what some of the different transports are up here with WebSockets, server-side events, Forever Frame, and Ajax long polling. You have a very low-level API called the Persistent Connection API. Almost no one messes with it. The reason is the Hub API is so much simpler to use, right? You don't really gain anything by working in the Persistent Connection API. You actually lose a lot of programmability and ease of use. Either below that on the client side or above that on the server side, you have your actual application code. So SignalR is a .NET API. So on the server side, you will be running .NET code. On the client side, you can run .NET code, right? There is a client-side library, SignalR library for .NET clients, but it will also run in any browser application. And we'll actually see this running in a variety of browsers tonight, not just Edge. So, transports, how it gets data from one place to the other. The transport that you want to use most of the time, and the transport that you'll be able to use with modern clients, modern browsers, right? So think Edge, think Firefox, Chrome, the newer versions, that kind of stuff, is HTML5 WebSockets. HTML5 WebSockets are true, persistent two-way connections between the client and the server. They are live, and, well, they're a part of HTML5, right? So they're a part of a standard. They are very efficient, and they scale extremely well. That's kind of the important thing, is they scale really, really well. So you can shove a bunch of data into this pipeline and not overload your server. Now, there is a limitation, right? And that is the pipe, the network, right? But outside of that, you will saturate your network before you saturate your server. HTML5 server-sent events, also known as the event source. This is actually supported in most current browsers, Firefox, Chrome, except for IE and Edge. It's not supported in IE and Edge. Now, what if you don't have a modern HTML5 browser? How many of us are stuck at a client or stuck with a customer who insists on using Windows 7 or, God forbid, Windows XP? Oh, I see. We have a couple of those, huh? You guys are looking at each other. Yeah, that's
Unfortunately.
yeah, you're talking about us, right? They use IE, what version of it? 10? Is it 10? Did they go up to 10 before they quit? Something like that. Using an old browser, right? How do you do this stuff? Well, for those less capable, shall we say, browsers, SignalR actually supports both Forever Frame and Ajax long polling. And these work a little bit differently, but the important thing is you can target those older browsers and use this functionality in those older browsers. I have actually done applications where SignalR is feeding into older browsers running on Windows 7, and it worked just fine. Now I will say things like Forever Frame and especially Ajax long polling do not scale as well. They are a lot less pleasant on the server, right? Long polling in particular, right? You open up a web request, you keep it open for as long as it takes for there to be a reply to come down. Ew, right? But the thing is, it works. And so you have this one single client or one single piece of server API that allows you to handle any of these, right, seamlessly and invisibly, right? The server software that you write using SignalR is blissfully unaware of how stupid that client may be, right? It will just work. Now, one thing I will say about WebSockets, from a server-side perspective, WebSockets does require Windows 8 or higher, or Windows Server 2012 or higher. Okay? If you're running, what was the Windows Server before 2012?
2008.
2008? Yeah. If you're still stuck with Windows Server 2008, you will not have support for WebSockets on the server side. But again, that will be invisible to you. So what are some of the use cases? Why would I want to do this stuff? Well, it's funny that we should talk about that because we were just talking about this at the office today, right? Talking about, so we're doing a workflow-oriented application, right? Where users are going in and they're defining workflows where they go and they change stuff out on a gas pipeline, right? It's an energy company here in Houston. Narrows it down a lot, doesn't it? How many energy companies are there here in this town? Lots. Right. So, wouldn't it be cool if, you know, when the workflow assigns a task to the user, if the user's in the application, it popped up a little toast say, hey, you have a new task. Or, hey, you have a new work request that's been assigned to you. Or, hey, you've got to go do this, right? Even though they weren't on the page where that happened. Like another user went in and did this that affected that user, right? Even though they didn't do a refresh, right? It just popped up for them.
Does it bring the phone and tell them to so that they're not at their desk?
Not quite.
That would be cool.
I suppose. Right? But this is certainly a good deal above and beyond just sending an email notification. Right? Now they do have to have an open connection and an active connection. Right? But as long as they do, you can push notifications to them. Where else? So there's actually another company that I've talked to with Hitachi that is a financial company that has offices here in town. And they're using SignalR internally for what? Things like stock tickers and trade notifications and that kind of stuff. Pushing it down to traders' desktops in near real time. Now, you'll see a lot of folks talking about it saying real time, real time, real time. Until we figure out quantum entanglement, as far as I'm concerned, we don't have real time. Right? But this is near real time in that it still takes a few milliseconds to go from the server to the client. Right? So the latency is very, very low. Multiplayer gaming. In fact, one of the demos that you can find out there is a multiplayer game built on top of SignalR.
Is this real stable?
Yes, it's very stable. It's actually quite mature. It's been out for several years.
In the early days, everything just flaked all the time.
This is not the early days of Signal R. Signal R has been out for at least 5 years. Yeah. So I understand where you're coming from. Long since out of beta. Yeah. Server-to-client remote procedure calls. How many times have you had or needed or wanted a way from the web server to call a JavaScript function on the client without requiring a round trip? Would that be useful in any apps that you can think of? See, this gentleman over here is going, yeah, yeah. Right? So this is some of the things that you can do with it. Or another place where I've used Signal R, long-running operations. So in a previous project I was on, this was a manufacturing company, they wanted to update their specs, right? And they wanted to do what they called a mass update, where they could update 150, 200, 300, 500 specs in one shot, right? Now, some of these specs were very complex. And that process, updating hundreds of these things, takes a while. Well, they wanted to have notifications of the progress through and which ones failed and which ones succeeded and blah, 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 and when it was done, yada, yada, yada. You know how users are, right? They think this stuff's magic. It is magic. Any technology sufficiently advanced is indistinguishable from magic, right? So that's what they wanted. We wound up doing it in Signal R. So they would kick off this process. It would go off on a background thread on the server, right, and start chugging through these things. And it would actually do multiple at a time, right? It would do them in parallel, right? And be chugging through these things. And as the different updates succeeded or failed, it would do a Signal R request back down to the client. And this was the client using IE in Windows 7. Yeah, I know, it's painful, right? And it would give them notifications of success or failure or completion or anything like that, right? So you can do it to provide status updates for those long-running processes, right? What about a query that needs to return, say, 5,000 rows into a smart client, right? What do we do today? We make a call to the Web API 2 server, right? We go and we pull all those records out of the database. We then send them all back in one big chunk, right? Serializing them as JSON. How long does that take? Takes a while, right? You got to go, you got to read them, you loop over them, you create the entity framework objects, you then take those entity framework objects, they get serialized as JSON, then they all get sent down in this one big, massive result, right? Wouldn't it be cool if you could go and as you're pulling the records back, right, as you're looping through them just once, right, you add them to a buffer, that buffer gets to a certain size, you send that buffer down to the client. You go fetch the next buffer. And keep on doing that until it's done, right? Pushing those records as they come back from the database, right? Because Entity Framework now streams results. It doesn't go through and create all of the entities before it returns the enumerable to you. It creates those entities as you were enumerating over that enumerable. So now you only have to loop through it one time, right? Significantly more efficient. There's all kinds of cool stuff that you can do with this. Now what we're going to do and what we're going to look at, what we're going to play with as part of our demo is everybody's favorite real-time type app, which is a chat app. Oh, by the way, it runs on mobile too. Someone I know talked to me and said that they had, it was Rozzy, he's got a chat app that he runs on his phone that he built using
Signal R.
Signal R. That's right. So it runs on mobile devices as well. Now, server components. Pretty simple. NuGet. Install Microsoft.ASP.net.SignalR. Right? It'll install all the dependencies, yada, yada, blah, blah, blah. How many of us do NuGet? How many of us love NuGet? Yes. We no longer have to worry about our dependencies. Yay! Right? So NuGet, that's all you need to do. On the web client, it does require jQuery 1.6.4, but that's really easy to get, right? How do we get jQuery 1.6.4 or whatever the latest version is.
Install anything else from NPM.
Well, there's that, yeah. Install anything, right? Or NuGet. And then you'll get Microsoft.signalr.js. And that will install the client libraries. And it's just that easy, right? For those of us who come from the old days, where you had to go and you had to find every dependency and this and that, and yeah, things are a good deal easier. Now, how do you get started with this thing on a web project? Well, you create a new web project. That helps. It's going to need to be a Web API, MVC type application. That's it. And then you go in, and in Visual Studio 2017, right? If you go in and say add item, you have this SignalR thing in here, and you have a SignalR hub class, and you just add that, and guess what? Presto Magico, it starts adding the references to your project for you. Right? So you don't actually even have to go out to NuGet if you don't want to. You just go in and say, I want to add a SignalR hub, and Visual Studio does it for us. Awesome. Right? Configure your ON startup class. Typically, all you need to do is app.map_signalR. Really. That's all you need to do. Now, if you want to get funky with it, if you want to get, and we'll see some examples of this, you can actually go in and configure some of the different settings. You can map it to different URLs, that kind of stuff. But to get started, really just app.map_signalR and start coding. That's really about it. And what you're going to start coding is your hub, right? Hubs are a higher level API. And this is what you did, right? You used a hub, right? We were just talking about you while you were gone.
Oh, really?
Yeah, your mobile chat app,
Yeah.
right?
It's actually a task management thing too. Like you were talking about the task flow, so you have a task and you chat within the task.
Oh, very
So
awesome.
It first alerts you that there's a task, and then it alerts you that there's a chat message coming in the task.
Oh, there we go. No, Michael, don't tell them that.
I'm not saying anything.
Yeah, I'm not saying anything because I'm going to have to wind up writing it.
If you want it, I can, share the code.
All right. So a high-level API is built on the lower-level connection API that we talked about. This is typically where you're going to want to work. Just a lot easier to mess with. Clients and servers call methods on each other directly, very similar to any other style RPC mechanism. How many of us have used .NET Remoting? How many of us loved .NET Remoting?
I did use it one time.
Huh?
I did use it one time.
I had to use it one time. How many of you, how about WCF Duplex? Right? Yeah. This, far simpler. Far simpler. I mean, getting WCF Duplex up and running involves sacrifices of many chickens. Right? This requires no chickens. No chickens are harmed in the creation of this SignalR project. Right? Very easy to do, but it's similar model to other RPC style mechanisms. Most of the time, you should leverage the Hub API. If you need to use a format other than JSON, right? Hubs will always use JSON. Is that okay with everybody?
Of course.
Yeah.
Nothing better than JSON.
Nothing better than JSON, right? They told us that everything would be XML one day.
They were wrong.
They lied, right? Everything is JSON, right? You want to deal with messaging and dispatching rather than remote invocation. Who wants to deal with low-level plumbing? That's what I thought. However, the one real use case is if you have to port an existing application, right, and you support existing code, but if you're greenfield, all the way, baby. Now, creating a hub, this is really about what it looks like, right? The hub name is actually optional. I like putting it on there because there are some rules about how it will convert this to a hub for the client, right? It'll do camel casing, it'll remove the hub from it. I like to specify it because I like to be very specific. I like to know exactly what's going on and control it. I'm a control freak. That's just how I roll, right? But it is actually optional. Then we have this method send. This method would be called from the client. So the client will call send, we'll write something out to a console so that we can see it, and then we say clients. Well, which clients? All the clients. And when do we want to call on all the clients? We want to call broadcast message. So this will actually look for a method called broadcast message that takes 2 string arguments on the client and call it. If it doesn't exist, it will simply ignore it. You won't get an exception or anything like that. That's where the tracing comes in. Darn handy. Right? Now, the client components, getting started, you connect to the hub. Connection.hub.url equals whatever the URL is, right? In this case, we're specifying it, right? If it's just connecting back to the server that the page came from, you don't even have to do that, right? Then chat, connection.chatroom. Now see this .chatroom? This is the name of our hub. This points back, whoopsies, to the hub name.
Case sensitive, of course.
Huh?
Case sensitive to the name, right?
Oh, yes.
Yeah.
That's the other thing that'll screw you up. It is case sensitive. And then you respond to the message, right? You create a function that the hub can call, right? So we create a function called broadcast message. So chat.client.broadcast message equals function, name message, right? This is straight up JavaScript, right? We do this stuff every day. It's not that hard. And then we do stuff when we get the message. If we want to send the message, chat.server.send, right? And then we send in our arguments. And that's really all there is to it. It is really, truly, honestly that simple. And Razi's over there going, yeah, it really is. It's really not that bloody hard.
Yeah, it really is.
So, let's go in and take a look at a very simple Signal R web application. And you'll see that I'm not BSing you. This really is that easy. So we'll come over here, where we have my Signal R demo web. And we will do, oh no, that's not it. It is first chat app, and here is our hub, right? And you'll see our hub. Let me make it bigger. Make it bigger, yes, I know, and I'll make it blue. Right? 'Cause nobody likes the black. The black background doesn't seem to work very well for presentations, yes, I know, but I love it.
It's good when you're coding them up.
It's good when you're doing what to who where?
If you have got like a screen in front of you, the black is fine, but on a projector.
Just zoom in rather than.
We've learned that 125% is a good viewing point on a projector.
Is that big enough?
Yeah, why don't you
A
zoom
little
in?
bigger.
Because this does it across the board, and because I'm old and that's how I'm used to doing it.
Yeah, better.
You should see how I typically code. I put it on like 8 point, and then I'll zoom out to like 83%. And it's like super small on my screen. And I have the black background, right? Because staring at white all day long, like it's eye strain, right? I'm getting old. I'm not as young as I used to be. So, here's our hub, right? And in this case, I don't even have the attribute on there, right? I'm just kind of blowing it in the wind, just kind of putting it out there, man. Hey, woo, right? So chat room, right? So what it's going to do is the hub name on the client is actually going to be chat room with a small c. It's going to camel case the puppy, right? And we have our broadcast message. We have send. I mean, this is really all there is to it.
Quick question.
Yes.
The send parameters, name and message,
Mm-hmm.
are those, why, okay, so why name and message? Why name? What's the name for?
It's a chat app.
Okay,
right?
okay, the
It's
name
you
of the person.
sending.
Okay, gotcha.
Right? It's your name and
Okay.
what your message is. These can be anything,
Yeah, method can be anything.
Okay.
right?
It just depends on the.
This is this
Okay,
can
I
be
thought-
anything.
okay, I thought it
And
was
in fact,
like-
when we get further on,
Right.
this style, I think sucks, and
Yeah.
there's a reason I think it sucks, and I'll tell you why I think it sucks, but later.
Yeah.
So you can't go anywhere.
Right.
Okay?
Right.
Good. So, send name message. Now let's go back to our client. Here's our client. So I'm referencing jQuery, right? And I'm referencing Signal R, right? And then this guy right here, look at this. what happens is, what the SignalR server component does, is it actually auto-generates JavaScript files for you. And it generates them at this SignalR/hubs URL. Right? So you actually want to bring that script in, because it's going to give you JavaScript goodness and just make our lives, yet again, that much easier. So here we go. We get in, and I have a call to the debugger. Right? So this is what you do when the breakpoints in the browser aren't working. You put in debugger, and then you always forget to take them out. And then you keep breaking in the application. And yeah, right? Michael back there, I'm working with Michael on the current project. He's like, yeah, we've been doing that. Yeah. So there's our debugger call, right? So I go, chat is connection to the chat room, referencing the hub. That gets our connection to the hub. I have the logging commented out. We can turn that. We'll turn that on later, right? Here's my method, broadcast message. So this is what gets called, name message, and it just prints it out to the page. So very simple, very straightforward, not a heck of a lot to it. So let's go ahead and I'm going to, let's make sure this is my start page. There's my set as start page. And I'm going to go ahead and I'm going to start a new instance. I'm going to fire up a couple of additional browsers. Right, so Opera is saying enter your name. So I'm going to say my name is Opera. For each browser, its name is going to be what the browser is. Hello. Right, and you'll see Opera says hello. Now we don't see this in Firefox or anything like that yet because it hasn't logged in. Right, so when you flip over here to Firefox, is this Fire? No, this is Chrome. Okay, Chrome works. So we'll say Chrome. And Chrome will say hello. Right? Now we come back over here to Opera and look. Right? We go to Firefox. Now watch, because you can see the Opera and you can see the Chrome in the background, right? That is nearly instantaneous. Now if I put a breakpoint on the server, so let's come to the server right here. Right here. I'm going to set a breakpoint right there. I'm going to say, don't suck. If I can type. Right? You'll see it is actually coming to the server and calling that broadcast message. We see our name. This is coming from Chrome, but we saw that. We see the message, y'all suck. Right? As soon as I hit F5, that's when it shows up in the other browsers as well. So how hard was that? I have real-time communication going between multiple different browsers. This is all working over HTTP. Port 80. What does that mean?
It's not encrypted.
Huh?
It's not encrypted.
Okay, so I'll put it on port 443. Happy? What does that mean? It means it's firewall friendly. Right? How many firewalls block port 80? Exactly. Right? So this can be done through the firewall. Cool? We ready to go start doing SignalR apps now? Guys, it's really not that difficult. Now, SignalR for Windows client apps. Unfortunately, it's a touch bit more difficult with a Windows client app. Just a little bit. Not a lot of it, just a little bit. Right? Windows client apps can connect to them. It's support for .NET 4, WPF, WinRT, Windows Phone, Windows Forms, anything with .NET, I believe it's 4.5 or higher. How many of us are still doing Windows Forms apps? I'm sorry.
If you want to know what I did for my app, it's still all Chrome, and I just used This package in Windows stuff without the one.
Okay, so you're using the native mobile browser. I do believe it also works. What's that API you work with, Tony?
Which one? Xamarin?
Xamarin.
Oh.
Yes, it works with Xamarin apps. Right now, the one thing about .NET apps is they're all going to be async methods, so you do have potential issues when dealing with UI-based applications, right? Because multi-threading. What happens when you call or touch a UI component from a non-UI thread?
It's a error, right? It's not error you get. I forgot what it's called.
It goes boom,
Yeah.
right? It goes boom, right? That said, it's easy to get around. Just make sure you use dispatcher threads to update the UI. To get started, reference the NuGet package, ASP.NET SignalR to client, create a new connection, create a hub proxy, and rock on. So this gives you an idea of what it looks like. Again, this is a little bit more code than we had in the JavaScript. Not a lot, just a little, right? We have a reference to our hub proxy, we have a reference to our hub connection, we create the hub connection, we create the hub proxy, passing in the proxy name, and then on broadcast message, Lambda. How many of us are familiar and comfortable with Lambdas? Yeah, I love Lambdas.
Does it also?
Lambdas are my friend. I do Lambdas for like everything. I'm like totally addicted to them. So, you'll do a Lambda. You can actually do observables, all that kind of stuff. We're not going to get into that here, but you can if you want to. And then this is actually using MVVM Lite and the MVVM Lite API to make sure that it goes on the dispatcher thread. This is using the MVVM Lite Messenger API, and it's just saying, I have a message, I'm going to send it out, right? And you'll see where that gets hooked up. And then you start, notice though, you start the connection and you wait for it to complete. So this start is an async call, right? So this wait makes sure that it completes before you exit the method. Otherwise, it may not be done when you exit the method. If this was an async method, this would be an await hub connection.start. Right? To call send message, right? Async task send message, and then we await invoking the message. And that is all you need to do from a Windows client app. So we have Windows clients, we have web clients, we have web server. What if you want to host it in your own Windows app?
It's Ionic, just like your.
Yeah, it's called self-hosting. They actually have a term for it. Right? You can use this in scenarios where IIS is not ideal. Usually you'll do it as a Windows service. What I have noticed is this has actually become quite popular with hardware manufacturers. How many of you build your own computers? Okay. So, companies like Asus, MSI, Corsair, and NZXT. For those of you who were talking with me before, you know I'm a big fan of Corsair, right? All these companies that I know of, because I've gone through just decompile and looked at what they're doing, are using SignalR. And they use SignalR to talk from a service that sits and talks directly to the hardware, to a client application that you work with. Right? So they're using it for inter-process communication on the same machine. Why? Because it's dirt easy, and it works, and it's efficient. Right? So this is actually pretty solid. To get started with doing this, you'll add the package microsoft.aspnet.signalr.selfhost. Right? You'll have to create your own open startup class to configure SignalR. If you're being called from a web client, you'll have to enable CORS. CORS is cross-origin resource sharing. Right? If you don't enable CORS, and you need to add this package, if you don't enable CORS, web browsers that come from a different URL, which is going to be just about every web browser, won't be able to connect to your service. Right? and then you start the web server. And it actually self-hosts a web server internally inside the app. To give you an idea of what it looks like, here's the configuration. Now this is the configuration including cores, right? So I'm saying use an error page to show all errors. You would want to turn this off in production. Map, signal R. In fact, you could actually just do app map signal R if you wanted, right? And stop there. But cores wouldn't work, so we couldn't connect to it from our browsers. So I'm going to say use cores, and I'm going to allow all. With use cores, you can actually go in and say, you know what, only allow if it's coming from these other resources, these other URLs, etc. Right? You can limit that. In the real world, you probably don't want to say allow all, right? Because that allows anybody. But you could. This is the hub configuration. Again, this is optional. I'm saying enable detailed errors, enable the JavaScript proxies. So I'm going to connect to this Windows client from my browsers. Right, so I do want to have those JavaScript proxies on there. And enable JSONP if you need to. Usually that's going to be false. Connection configuration, and then run signal R. That's it. That's your configuration. That starts up the server. Opens everything up. You now have signal R channels open and ready to go. Actually, you have to do this. So this right here. So this is in a console app. It's saying our app URI is localhost 8080. That, by the way, using localhost :8080 means it will only be connected from localhost. If you want it to be connectable from outside the machine, number one, you do have to turn off. You have to allow the port through Windows Firewall, right? And you would do things like star or whatever. Web app.start, and away you go. And this is kind of the same thing over again. I don't know why there's two slides with that. I know why. So let's go ahead and take a look at Signal R in a web app. I mean, in a Windows app. Right? So first, we have our console host. Right? And here's our startup. So we saw this. This is exactly what we just saw on this slide, right? We're using cores, we're setting our configuration, and running Signal R. And here's our startup. Setting my app URI. Now, in this case, yeah, we're actually going to turn this off for now. We'll see this later. So you didn't see that. We'll just hide it. Pretend it's not there. All right, and it'll give us a message that the server is running, and then just sit there and wait. And what we're going to do is we're actually going to connect to it from our browser clients, right, as well as a Windows client. So we do have a Windows app, which has a remarkably gorgeous and intuitive UI. Hey, it's MVVM, dude. Right? This is all MVVM, so it's advanced. I know. UI design is not my strong point. Right? So we put in our name, we put in our server URL, and it will show the messages in a list box. If we take a look at what's going on behind the scenes, right? I did wrap everything up in a Signal R chat client. Notice it is implementing iDisposable. And the reason is this guy right here is disposable. So if you have a private member variable that is disposable, what is it that you shall do?
Dispose.
Thou shalt implement iDisposable as well. Right? Yes. Good. If you don't, that makes me angry. Now, there's our hub connection. We create our hub connection. We create our proxy. I'm turning on the trace levels. Let's turn these off for now. Right? On broadcast message. This we're saying we're using MVVM Lite's Messenger API. I'll show you where this winds up going. To broadcast to send the message across the application. We're catching any exceptions. This is how we send our message. the message gets intercepted by this main view model right here. Right, so you'll see in the main view model, I have messenger.default.register. So this is actually registering for the chat messages, and it's going to call message received when a chat message comes in. And that is somewhere down here. Yep, message received. And then in message received, we're calling UI dispatcher, invoking async, and adding to our messages collection. Because this is where we're touching the UI, so we make sure we do it on a UI dispatcher thread. Otherwise, things go cool. And that is bad. Right? And that's really all there is to it. So let me go in and just make sure that main window is my startup window in my WPF app. And so what I'm going to do, so the console host, the chat client, there we go. So I'm starting up console host, the chat client. You know what? Let me go ahead and start up the demo web 2. Right, so I'll start them all up. I'll get everything kicking. So what do we want to do? Do we want to use the web server first, or do we want to use the console server first? You tell me. Huh?
Well,
Web? Okay. So that is localhost. Oh, I don't think I started the right project. Let me try that again. What I need to do is take this guy out. I'm not using yet. Okay, first chat app, SigmaR console. There we go. Okay, I'm good. I did have that one starting. I just screwed myself up. All right. So this one is, I don't even know what browser this is anymore. Opera. So Opera has entered the building. Right. And it works. Yay. See it going to the server. Let's go ahead and get the URL. Localhost 2838. Then we'll come into our Windows app, and I'll say WPF, HTTP, and copy the HTTP for me. There we go. We'll say connect. So now we're connected. See, it's a really wonderful, intuitive UI, isn't it? Notice it's going into the same, and we notice we're now actually talking from the Windows app into the web app. And we can talk from the web app into the Windows app. Right? Now, if I had this opened up, y'all could connect to it from a browser on your machine and do the same thing. And it would work seamlessly. Now let's go ahead and restart this real quick. And I will set this as my first chat app. All right, so here's our self-host chat, and I'll set this as my start page. right? So Opera is connected, and then this is going to be 8080, right? So that's what we set it for here. Right? And you'll notice I have the console app giving us a write line whenever it receives a message in. So we can actually see this going on. See, everybody's first app is Hello World in Texas, though. Because we're in Texas. It's Howdy World. Right? So you can see it's going back and forth. And in this case, our console app is the host. So any Windows application can be the Signal R server host.
So the self-hosting, what is the, it's not using IIS, is it using IIS Express, or is it using Container, or what is it using?
This?
Yeah.
It's actually hosting the web server internally. It's self-hosted.
Little web server.
It's not IIS. It's, I don't know how to explain it, but it's been a part of the .NET framework for a while.
Is it Cortana?
See, it's
or- sorry,
No, Owen.
Owen.
Yeah, well, it's Owen based, right? But Owen is just middleware that sits on top of a web server.
So it's just a little server. A task.
Now, we've actually used this to pump a lot of messages, that little server. Because back when I was doing the Stream Insight stuff, right, we used Signal R and we were pumping thousands of messages per second through that channel.
One question. Basically, you saw that you are sending the messages back and forth.
Mm-hmm.
Can you open the streaming from one side to start streaming? You know,
It's
data?
message based, so they'll be sending one message at a time. It's not going to be sending a direct stream, right?
And another question.
Mm-hmm.
So back in the days, it was like 2 years ago when we started. It was like Windows 7 client that we used. We had always the problem with the connection. The client just dropped the connection. So what we used in the connection to grab that event or disconnect and reconnect again all over again.
We'll talk about that.
Okay. Thank you.
That is much less of an issue though with WebSockets, right? Part of the challenge that you were facing is that you had a Windows 7 client. Windows 7 doesn't support WebSockets, right?
Because
So it was
that
using
the
it was
issue, but it's not just that. Because
it was
once
using
you-
long polling.
Yeah, and then once when you open the fiddler or something like that, then you have.
Oh yeah, yeah.
It was a mess.
It was using long polling, right? Because that's all you can do on Windows 7. Windows 8 and higher, so Windows 10, that kind of stuff, is all going to use the WebSocket support by default, right? It will do the best that it can.
Because, sorry to interrupt, but in those days there was like kind of, cascade. So if you cannot connect, then it's going to automatically
Yep.
try the lower and
Yep.
the way. So
Right, and the first method it would try to connect would be WebSockets. If it couldn't do that, then it would go down one,
so
then it
it's
would go
still,
down.
it's still using that.
Yeah, it still does that. Yes, absolutely. I kind of talked about that in the beginning. It will downgrade gracefully, right? So if you have a stupid client, it will do stupid things, right? But where we are today, Windows 8 going away. Windows 10 is pretty widespread, and particularly on the browser level, right? Chrome, Firefox, all of the latest versions of those all fully support this, and so they'll be using WebSockets. Edge fully supports it as well.
But it's still message based.
It is still message based, yes. Now, some common gotchas. I talked about this quite a bit. I hinted at it. Right, Signal R uses camel casing for hub names, method names, etc. Right, so if your names are incorrect or whatever by case, they won't work. That's probably the single most common gotcha, is getting the name wrong, and it drives me nuts. My advice: don't rely on the default behavior. Just use the bloody attributes and control it. Right? Define it, control it. It doesn't take a lot of effort, saves a lot of headache. Why do you think I shave my head? Don't pull my hair out, right? So, I recommend, my suggestion is to use the hub name and hub method name attributes. Don't rely on that default behavior. Control what those things actually are, and it's going to be a lot easier. SignalR does use JSON by default. If for some crazy reason your client doesn't have a JSON parser, and I can't imagine why that would be the case, but let's pretend it is, that would be a problem. The other one, and this is another one that gets folks a lot too. The subscriptions to the client callbacks, right? You'll notice in both our JavaScript code and in our WPF code, we said the on whatever before we actually called connect, right? You have to subscribe before you connect.
Yeah, I learned
You
that
cannot
from
subscribe after you connect. You learned that the hard way, right? Yeah. So Rosie over there saying, yeah, that one's true. Because,
You can't find your method if you don't register it first.
right. And this is true for both .NET and JavaScript clients. So regardless of what you need to do, you do need to configure your subscription callbacks before actually starting the connection. Which brings us to tracing, right? When stuff's not working, how do you debug this stuff? How do you trace? How do you see what's going on? So, on the server side, you can use system diagnostics. There are 10 different trace sources that are baked in. A couple of them are more useful than others, right? But you define those trace sources in the configuration file. You turn them on. You start writing it to a file. You start writing it to a console, whatever. Right? Particularly if it's a production server, you're going to write to a file. This will show you a whole wealth of information of what's going on at the SignalR level. Right? So that will help you define what's going on the server side. On the client side, on the JavaScript client, you set the logging to true before starting the connection. You will then have events logged to the console, right? The browser console. We're all familiar and comfortable with the browser console, right? We love the browser console. Yes. So all of your events will be logged there. You will get a ton of information, more than you ever wanted to know. Still, darn handy when you get those method names wrong. Because you will see messages in there, could not find this message, could not find this method, right? On the .NET client, you can set the connection trace level to your appropriate level. Set it to the lowest and output it somewhere. Right? We'll have it going to the debug window so that we can see the messages. But you set your trace writer. You can write this to a file, you can write it to wherever. Right? Again, you will get a wealth of information about what is going on with that connection. So without further ado, let's go ahead and take a look at what kind of tracing we get in SignalR. We come over here. Figure this out. Right, so I will start off and I'll just copy and paste. Put it in here. Right, and then we'll turn our logging on. Right, so this is going to log to our browser console. Let's go to our web config. Now in our web config, notice I have them commented out. These are all the different listeners that we have. Right, you have listeners for all the different events. You also have listeners for integration points that it has with different Azure services. So yes, this does run in Azure.
Is this basically the Azure notification hub?
Yeah, so some of the different notification hubs that they have on Azure, right? So you have support for the service message bus, the Redis message bus, the scale out message bus, the SQL message bus, right? In our scenario, we actually don't need these. They won't report anything because they're not being used, right? But the different transports will. So those are being turned on. I'm setting it to verbose. I'm using the default trace listener, which I hope will write out to the debug. And then on the simple chat client, let's come in here. And there we go. We'll go ahead and do the same. Right? We'll set our trace level to all, and we'll call the debug trace writer. Right? So this is going to write a whole bunch of stuff into my debug output window. Right? I'm going to see all kinds of things going on there. Right, so we see our loading messages, and what I'm going to do is reduce some of the output. Right, so I'm going to come in here. So we've got our server running. I'm going to go ahead and connect to my server. Actually, no, I should connect to the web server. That's going to be 28328. Now, as we go into Visual Studio, you'll see we have client trace, change state, client trace, connecting, right? Transport heartbeat, WebSocket transport, right? Sending outgoing message, right? So this is all the stuff that's coming from the tracing. I didn't write any code for this. I just enabled the tracing. That is all I did, right? We're seeing a keep alive, right? So this keep alive is going back and forth occasionally so that the server knows that the client is actually still there, right? It's a little heartbeat. If I come in here to WPF and I send something, howdy y'all, right? There's our breakpoint.
So you can send HTML.
Yes, you can send anything. And we'll get to that, right?
It's serial.
So you see that sending outgoing message, sending incoming message, yada, yada, yada. You should see what Corsair Link actually transfers back and forth. It's they actually transfer binary, and then they decode it on the client.
Oh, so it's in binary? Or is it serialized?
It's serialized. Yeah. I've hooked up to it. I've looked at it. Right, so these are the different messages going back and forth. You'll see, right, on message, C, D, blah, 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 blah. Oh, look at this, H, chat room. What do you think that is? Hub, chat room. M, broadcast message. Argument, WPF, howdy y'all. So you can actually see what's going back and forth. Isn't that nifty?
So if you now close the client, it's going to... If you close the client, it's going to send the message that the client is kind of disconnected.
Well, I closed the client. Now we see we have a socket transport, one error. And we see it closed, right? But we see the socket being closed. Now we still see a heartbeat. I think that's coming from, it might be coming from one of the, yeah, it might be coming from the browser. One of the browsers. Oh, no, no, no. The heartbeat, notice it's saying, client is dead, client is dead. Right?
Number of retries.
And now it's saying removing the connection, canceling, draining, completing. Right? And we'll get into what's going on in just a minute when we talk about connection lifetime. But there's actually a madness to that method. Before we get into that though, let's talk about, right, so you have a SignalR server. So your chat service that you were talking about, this little task thing, right, a lot of times you're chatting just between two people.
Right.
Right? You're not broadcasting those chats to everybody, are you?
Obviously not. Yeah, that's the tricky part.
Is it obviously? Well, I'm sure there are some messages that you broadcast to everybody.
You can, but yeah, mostly it's just between specific clients.
Yeah, just between specific clients or between specific groups or whatever, right? So in SignalR, you can target specific clients. First, you can target specific groups of clients. So this can be handy, right? You have multiple people in a single chat room. So that chat room can become a group at the SignalR level, right? The groups can have any number of users, actually any number of connections. A single user can have multiple connections. There are times when that can happen. A user or a connection can be a member of any number of groups. So it's a many-to-many relationship. And they can be a member of any number of groups at any point in time. However, keep in mind, when using groups, groups are not persistent. There is no persistence mechanism. SignalR doesn't remember what your groups are. Right? They're gone. They're also not something that you manage. There is no group API. There is no group discovery API. You can't say to the SignalR server, hey, what groups are there? That doesn't exist. If you want to do that, you have to write it yourself. Can you do that? Absolutely, right? We can write code. But it's not there as a part of SignalR. They are dynamically created, right? You don't go in and you say, create group, do this, do that. No. As soon as a client joins a group, that creates it. They are also dynamically deleted. They are gone when there's no one left. When all the connections are out of a group, the group goes away. So are these very ephemeral kind of things that come in and leave kind of as you use them. That said, they're very, very, very simple to use. To add a connection to a group, you say add context.connection ID, and then what the name of the group is. That's it. Removing, remove. Send a message to the group. Now we've seen clients.all, right? This is slightly different. Clients.group. What's the name of the group? Then send message. Sending a message to a group except for specified connections. When might you want to do that? Again, that chat app, right? You don't send it back to the person, they know what they just said. You can go ahead and display it right there, right? So you can send a message to a group except for specific connections. Or send a message to others in the group, right? Overloads exist to send messages to multiple groups as well. So you can have groups of groups. Again, this would be something that you would write and put into your application. It works quite well. Now, outside of groups, you can also target individual users or individual connections. Right? You can target by connection ID or by user ID. Now, the user ID is a construct that you have to tell SignalR how to determine what the user ID is for a specific connection. And you do that using a user ID provider. Right? We'll see this. SignalR will use this for sending by username, and really, very honestly, not much else. To send by connection, you say client.client connection ID, send message. To send by user, client.users, pass in the usernames, send the message. Okay? Now, when sending by username, it goes to all connections associated with that particular username. An individual username may have any number of connections associated with it. The username is not inherent to the connection. I already talked about this. If you need to, you may need to track connections and usernames yourself, right?
Yeah, so coming back to my app, personally, actually, when I did it completely on my own because users can sign up and then you have a user ID and then the user can connect from the phone or from a desktop app or from a web client, and that one user has multiple connections. So
right.
I kind of didn't use this. I just wrote my own thing to handle that. But yes, the connection IDs comes from the hub. So anytime a new user connects, so what I was doing was that whenever you connected, it sent the user ID to you saying that, hey, I'm this guy who's logged in, and then I get the connection grid, so I store it on the server side, and okay, this user, so every time you want to broadcast to, like somebody sent a message to the user, it would send it to all the connections that
You probably could have simplified yourself by wrapping it
yeah,
up
I
in
used
user
to
ID
do that,
provider.
but I mean, sometimes it's easier to write your own stuff than
Sometimes, yeah.
I have a question.
Yeah.
Can we set up to get the pass message, the message up before you connect to the group?
You would have to manage that yourself. SignalR isn't going to do that for you.
Then how do we, oh, okay. Then how do you do it? So you have to figure out all the timing and...
If you have a requirement for that, right, you would want to store like past n number of messages or whatever, either in the application or some sort of durable store, and you would have a method called get past messages that would then return them, right? Using things like reactive, right? Reactive has similar type functionality where you can do replay, right? Because that's what you're talking about. You're talking about replay.
That's when you join
Right?
the
It's not inherent in SignalR,
Okay.
but you can write code to make it do that.
Okay.
Okay? So let's take a look at client targeting. And to take a look at client targeting, we're actually going to jump over to our Chat Client V2. Now, Chat Client V2 adds a concept of rooms. Right? But Chat Client V2 does a couple of things differently as well. So let's look at that hub, at Chat Client V2 hub as well. So you'll notice, for Chat Room V2, right, it's in a separate assembly. Right? I took it and I abstracted it out into a separate assembly. Now, why would I want to do that? Huh?
Code share.
Code sharing. Right, yes. I want to be able to host Chatroom V2 in either a web app or a console app. Perfectly reasonable, right? The magic of object-oriented programming. Right? So I took it and I abstracted it out into a reusable DLL. I also have a user ID provider that actually grabs the user ID from either the header or the query string. So the client has to give me their user ID. It's kind of a cheesy way to do it. From a security perspective, right, we're not getting into the security, but security will work just like it works in any other web API app. Right? So you have all of the different rich functionality of web API application security that you can leverage in these. We're not going to get into that because that is a whole talk unto itself. Right? Just to let you know that you will. In this case, we're either sending a header from WPF or a query string from web, right? With the username, and so this is our user ID provider that will pull that out. Now, the other thing that we are doing, and this is how I actually like to have messages go anyway, right? When I call send message, I'm sending an object, right? I'm not sending a list of arguments. I'm sending an object that gets serialized as JSON. Now, why would you want to do that instead of a list of arguments? Huh?
And you can send more stuff, more data, you can send the whole object. Why would you don't do that?
Yes, well, that's certainly one reason.
Flexibility.
Easily.
What do you mean by flexibility?
Well, it gives you an arbitrary argument list.
It gives you an arbitrary argument list. So when you come out with Chatroom V3 and you add arguments to it, you don't break existing clients, right? And guess what? You don't have to go find where you redefined all of your messages, right? You change the object and poof, everything flows through. So yes, flexibility, maintainability, ease of use, exactly. That is the big reason for it. Makes your life simpler, right? So in this case, we're sending a chat message object.
You said about streaming.
Hmm?
You mentioned you can use this to stream.
Stream as in as you get results, you push them down to the client.
Not TV show.
Not TV stream.
Okay.
Yeah, no, not that kind of stream. There's so many types of streams. There's file streams, memory streams, zip streams, crypto streams. Streaming everywhere. Oh yeah, and then there's the water streams too. There's that. Can't forget that.
Do people ever use SignalR to say update maps? you know, or
I
drafts.
suspect
I mean,
pretty
I'm trying to
strongly.
think how I can do that, right?
I suspect pretty strongly that there is a traffic app out there that uses Signal R to push down route changes and real-time notifications of things like police, road hazards, and other stuff that other users report. What might this web app be? Waze, that's right. I haven't looked at it, I haven't decompiled it, I haven't dug into it, but I would bet, like, my HDNUG tickets, that they're using Signal R.
That's a safe bet.
Right?
What's the name of
Or actually, I would bet that they're using WebSockets. They may not be using Signal R specifically, right? But they are almost certainly using the functionality that Signal R is built on top of, which is HTML5 WebSockets.
A past client of mine, we use it for server, for services, for service detection, service monitoring.
Okay, yep.
So if a service dies, it'll send a message to the client saying, hey, your service is dead.
Yep.
We have monitors of services all over the screen. If it turned red,
And it's real time.
it's real time.
Yeah. So before, right, we would do things like WCF duplex. We've done that, right? Painful. Right? That's painful. .NET remoting. We've done that. Painful. Right? I use Direct Play for similar type functionality. How many of you have heard of Direct Play? Direct Play was a part of the DirectX API for real-time gaming, and I used it to feed stock tickers. Worked beautifully. Yes. Right? Hey, I mean, it's a similar problem to online gaming, isn't it? Yeah, it is. How many of us have used, the horror, DCOM? Yes. Right? So let's be honest, right? Remoting was less painful than DCOM. WCF duplex was less painful than remoting. Signal R, as you can see, is really not painful at all. Right? So we're making progress.
So do any of these messages actually travel through like the middleware, or does it skip over that entire mechanism entirely?
You know, the middleware term really disturbs me. It does travel through Owen,
Okay.
and Owen describes itself as middleware. I grew up with like the first terms of middleware, which were these big beastly things. So I have a hard time conceptualizing Owen as middleware when I think of a J2EE server as middleware.
Yeah.
Right? So you kind of see where I'm going with this. I'm confused by what's happened to the middleware term these days.
It's gotten better.
Yeah, okay. Right? So, we're calling it username. We're unfortunately running out of time, but I will make all of this code available. But in this case, right, we're saying, we're actually doing a lot more here, right? I'm actually hooking up the unconnected. So as clients are connected, I'm sending out a message to all users saying that someone has connected. And when they disconnect, I'm doing the same thing. Right? When they reconnect, I'm also doing that. And these are all coming from sysadmin. And then we're joining rooms. So I now have a join room, right? Where I'm saying I'm adding this connection to the room. And then I'm sending a message out to the room, right? From user, room name admin, and then who has joined the room, right? Who has left the building. And you'll also see in send message, right? So send message takes a chat message in. So let's take a look at chat message now. Chat message has actually expanded a bit. I have an array of users for directed messages to individual users. I have an array of rooms for directed messages to individual rooms. And then I have who it's from and what the message is. Right? So I've expanded the concept quite significantly. If we go back, oops, it helps if I do control minus. Right? If we go back to here, right, in send message, you'll see the first thing I do is I check to see if we have messages directed to an individual user. Right? If we have a message directed to an individual user, then I send a direct message. Right? This is a direct user-to-user message. Then I check to see, hey, is this going out to specific rooms? If it is, then I'm going to send it to the rooms, but I'm going to exclude any users that they specified. Right? Why would I want to do this?
So they don't get it twice.
They don't get it twice, or 3 times, or 4 times, right? Because you know, as well as I do, that they are not going to be amazed by the wonderful technology that you have put at their fingertips. Right? Instead, if they get the same message twice, they are going to call you up and going to say, I don't care about all of this amazing, wonderful stuff that you did that was so impossible to do 5 years ago. I want to know why I'm getting this message twice, because that's really making me angry. Right? Isn't that what they're going to do? Yes, we know this.
No kudos for you.
Yeah, you know, you do all this amazing stuff, and then they come back and they get their head wrapped around the axle because the color is blue.
But there's so much more you're missing out on.
Why not make that an else if?
The reason it's not an else if, right, is because if you specify both users and rooms, it should go to both users and rooms. If it's else if, right, it would either be users or rooms. Right?
Okay.
Because if I say I want to send a direct message to Michael and the right side of the room, I want it to go to both. Right? Now, you could do an else if, in which case your functionality would be you either send a direct message or you send it to a room. You don't never do both. Right? I'm saying you can have your direct message and your room too. You could do an else if, but you would have slightly different functionality.
Different use case.
Different use case, yes. And I'm not saying it's an invalid use case. It's just not my use case. Because this is my demo. It's all about me. Right? Now, in this case, right, in either way, if the message gets sent, I set the message sent to true. Right? So that way I could be very lazy here and just say, if the message wasn't sent, then it's a broadcast. Right? Now I could have said, if users is null or not users any, and chat rooms is null or chat rooms any, blah, blah, blah. But I figured that was just simpler. This was lazy, is what this is about. That's all.
It's actually faster.
Probably too, yeah. But it was more about the lazy. And the fact that lazy is faster is just a nice bonus. All right? So that's what's going on there. So let's talk about, this goes to your question, is the connection lifetime. Right? Now, you have connection lifetime events. The hub provides them on the server side. We actually saw those. You also have them on the client side. But this provides you an opportunity for setup and, if necessary, any teardown. Right? So what will happen is, if a client is disconnected, on the server side, you will get an on disconnected event. You'll also get that on the client side, if the client is still alive. Right? If the client crashed, they're not going to get an on disconnected event. But the server will. When? Eventually. It actually has a timeout for retries. Right? And we actually saw that, right? Remember, we saw that heartbeat, client's there, client's not there, client's not there. Okay, I'm done with this heartbeat, right? We're shutting it down, we're tearing it down, right? So we actually saw that happening in the tracing. You cannot, however, at least at this point in time, directly disconnect a client from server-side code. We're talking about doing that in a future version. But you cannot, from server-side code, say connection dead, right? You could have a message that you send out to the client that instructs them to disconnect, right? But this is like the days of Win31 cooperative multitasking, right? Do we remember Win31 cooperative multitasking? Multitasking worked really well as long as everybody cooperated and did what they were supposed to do. If they didn't do what they were supposed to do, what happened? Shit broke. right? This is why we have preemptive multitasking in modern operating systems, where the OS is in control of whether or not you cooperate. Because too many programs were bad little children, right? The same is true here. If they are bad little child clients, right, and they don't respond to your disconnect message, there is nothing you can do about it. Now again, they are talking about implementing this in a future version, but it's not there yet.
You should filter them out.
You could filter them out. You could do, yeah, you could do all sorts of other things, but you can't. They'll still have a connection at the end of the day.
Is there a limit to connections?
How big's your pipe?
Are they all open at once, or?
If they're all WebSocket connections, you can scale up pretty high, right? If you have all IE7 clients, you're not going to be able to scale up anywhere near as high. Now, you also have scale out capabilities, right? So you can actually scale this out across multiple servers. Now, you will have challenges, right? Because you'll have to distribute stuff, things like Redis cache and that kind of stuff, to distribute stuff across multiple servers. We actually saw some of the API functionality for that, right? The SQL Hub, that kind of stuff, is for that type of scale out.
What are you doing a server farm?
What's that?
What are you doing a server?
That's what I'm just talking about right now would be a server farm, right? You do have to have a back channel between them,
Okay.
but there's functionality baked in for that back channel to be there,
Okay.
right? Clients, right? So the hub proxies provide events for connection, on connection slow, on reconnecting and disconnected, right? They will typically get connection slow first. They will attempt to reconnect, and they will get disconnected, right? So you'll get connection slow, then reconnected if it comes back, right? Because if this is going over the public internet, right, it can be transient, right? Who the heck knows what's going on between point A and point B, right? The clients can disconnect by calling stop, right? That will raise on disconnect on the server. That disconnects them on the client. Couple of connection lifetime examples. This kind of goes through, this is physical connection interruptions detected by the keep alive, which we actually saw. What we didn't see was the recoverable, right? So on the connection on the server, we get on connected, client calling start, right? We see things going through, right? Now, the client in here, right, we detects these gaps, gets the connection slow event, and the reconnecting here. On the server, we see the on reconnected, right? So we actually know that, hey, this client has had some difficulties. The client also knows that they're having trouble, right? So on the client side, this actually gives you the ability to present messages saying, hey, you know, something's not quite right here. We're going to try and get these through, but we're not really sure. The connection's kind of iffy, right? So you have that information available to you. And we're not going to go through these one by one. I will post the slides for y'all to download. But these, I did not create these graphs, right? They are far too, you can tell by the fact that they're pretty that I didn't create them. All right? I know my limitations. Making things pretty, that's one of my limitations. I'm honest about it. I'm comfortable with it. I accept that about myself. So I stole this from the website. So this is all up on the these are all up on the SignalR website with a good deal more explanation. Now, the other scenario, right? So what we've been talking about in our demos is we have been calling the clients from within the context of the hub, right? One client calls the hub, right? That then sends stuff out to the rest of the clients. That covers some amount of use cases. But I don't think it actually covers the most interesting ones, right? The most interesting ones where we are calling a client from outside the hub, right? From server-side code that's doing other stuff, right? From a workflow engine, right? From a sensor, right? Or something that's monitoring the event log, right? Something that's going on over here, right? But wants to call this connection over here. So how do we call SignalR from outside the hub? It's actually not that difficult, but you need to be careful. Number one, the hubs themselves, they're not static and they don't maintain state. You can't say new hub and send a message. No worky. It won't work for you, right? Creating a hub outside of the hub pipeline, not going to do it. What you need to do is use GitHub context to get a reference to the hub context, right? And then you send it out. And it will magically start appearing to the client. So very similar to everything that we've been doing, right? Just a couple of lines of code, but this is the got you. If you just say new hub, chat room v2, nope, sorry. Not going to work for you, Charlie. Right? When you do global host connection manager get hub context, it will.
It's going to, sorry, there's no question.
Sure.
So the server in that case is going to connect, or actually send a message to all clients that already been connected.
Correct.
Okay. Not
Yeah. Not every client out there in the world who's not connected, right? So the client does have to initiate the connection first, yes. So let me show you real quick what that looks like. And I did it here in my console host. And you kind of saw this in a little bit, right, with this thread right here. Right? So this thread right here, I create in the console host for Chat v2, I create a thread that while it's running, every 10 seconds sends out a message to all clients for the system uptime. Right? So I start up the server, I create this thread. It kind of goes and does its thing, right? So the thread's running over here, right? Keep on doing its loop-de-loop, right? And it's sending out messages. Now, what I did is I made this a static method on my hub. Why did I do that? What's that?
So it's all the time accessible.
Well, so it's all the time accessible, and all the code relating to that hub is in one place. Right? So this is one way of doing it. Right? But in this case, right, so I'm creating my chat message, but you'll notice context, global host, .connection manager, GitHub context, and the name of it, right? This is exactly what I told you we needed to do. This is exactly what it's doing, right? It's creating that context. So even though it's in the same class, and I put it in the same class for manageability, right? Because I want to have all the code related to that chat room in the chat room class, right? Not scattered here and there and everywhere. Because then it becomes a maintenance nightmare. Right? But it's still being called from outside the context of the hub. It still has to get the hub context and broadcast the message. But that's it. Right? So what I will do is show you this working real quick like. I'll come into main window 2. Oh, main window, I'm sorry, V2. There we go. Now it's happy. And in this case, I'm going to connect to that V2 chat room. All right, so you'll see this has room names and that kind of stuff. And I'm going to connect, notice my sysadmin, right? There's my system uptime. Right? And you'll notice down here, right? It's still spitting out all of the logging. Now I'm actually seeing my messages. Remember we saw A and it was an array of 2 variables. Now you see A, our argument, and it's a JSON object. Yeah, we love JSON. Right? They named it after me. Right? Yes?
I thought it was your child.
Yeah.
Your son.
Yeah. Oh boy. You know, I'm going to tell Harley that and he's going to look at me and he's just going to shake his head and walk away and go play Overwatch. All right. So we see this and we see the messages actually coming and we see that they're coming every 10 seconds. right? So this is exactly what we were talking about, right? And it can be called from outside that hub. So you don't even directly need the reference to the hub context. Now again, from a code perspective, I put it in the hub class, right? As a static method. So I could get to it from anywhere, and so that all the code related to that hub is all in the same place, right? But I did that for me as a practices. All right, Azure, supported in Azure App Services, right? The one gotcha is by default WebSockets are turned off on the app services, right? But all you need to do is go into your Azure portal, go into advanced or so in the configuration, right? And you just say on and apply, and that's it, right? But that's something that you need to be aware of. If you don't do that, SignalR will still work. However, how will it work?
Another level, wherever that level is, get the one below it.
Right, it's going to do long polling. It's going to do
That's a big
forever
jump,
frame.
right? So is it? So the
Or server events. It's going
Okay.
to depend on what the client, but it won't do WebSockets.
So what? I mean, so the order you showed us earlier, is that the order it goes in from top to bottom? Okay.
Yeah, WebSockets, server events, forever frame, and then long polling, I believe it is. I might be wrong about where the other two, which one's priority, right?
Right.
But you want WebSockets.
Right.
If you're using multiple instances and they need to interact with each other, you will need to do the Azure Redis cache backplane, right? And that will help you coordinate between the multiple instances. I haven't actually done this in person, so I don't know all the dirty little details or gotchas yet, right? But that's what they're telling me. It will also work with things like message bus and that kind of stuff. All right, so as we are coming up to 9 o'clock, let's wrap it up. Number one, first statement, SignalR enables real-time bidirectional communications with clients over the internet. We good with that? You see that? Now, number two, this one's most important to me. SignalR is really simple to use. Would y'all agree with that statement? Yeah, it's really actually dirt easy. And a wide range of clients with very different capabilities. I talked to you about a couple of examples. We were playing in multiple different browsers, right? Multi-browser support, that is like the bane of web development, right? Write once, debug everywhere. That's not Java, that's web development, right? But it works in a wide variety of clients, Windows clients, browser clients, smart clients, dumb clients, with different capabilities. It will scale down based on their capabilities. So, any additional questions? And yes, I will make both the slides and the code available for you to play with, if you wish. Yes?
Is there ever a chance that it'll be available for like a node-based system?
Don't know.
I guess you just use your regular sockets they have already, but...
Yeah, Node may have built-in support for something similar. I'm not familiar with Node, so I don't know. So I'm not going to tell you one way or another.
Yeah.
I'll just say I don't know.
Yeah.
So can the monitoring tool detect whether the signal server is up or down or not working?
The client?
No, the monitoring tool, the tool that monitors all the servers, like all the web server.
What, in Azure?
No, any monitoring tool that monitor if the web server is up or down. Can those monitoring tools?
They would have to connect to a hub.
So the web service will have
But
to...
it's not generic. It has to be generic, right? If they connect to the hub.
Well, how do they detect if the web server's down? They make an HTTP request to
Yeah,
it,
right.
right?
Yeah.
This would be over HTTP. They would instead connect to the hub.
But how do they detect if the message is not sending back and forth to the client?
Now,
And
Yeah.
and then
You would do an ACK or NAC, right?
for HTML,
Hmm?
for HTML, what do they get?
Well, no, because this is WebSockets, right?
Yeah.
But a monitoring tool would have to attempt to connect to the hub and maybe put something in your hub that acknowledges, right? But I don't know, as long as they can connect to it, right, then it should be up. That should be all that they need to do, is just connect to a hub. Did I make a successful connection, yes or no?
then how does it know
connect and disconnect.
Well, whatever the monitoring tool is, right? The same way that it checks to see if the web server's up, right?
Right, yeah.
They check to see the web server's up by sending an HTTP request, right? The correlation to this is to send a WebSocket connect request, right? So you send the WebSocket connect request, the connect is successful, okay, I'm good, disconnect,
Oh, okay.
right?
Is this out of date?
I don't know. Let me see.
I don't think Signal has changed them no since it's started.
What year is it? Is this on Signal R1 or 2? The thing is, a lot of the stuff with Signal R1 still applies to Signal R2. So I would say it may be a little bit, at most it's a little out of date if it's like focusing on Signal R1. Signal R2 adds some additional capabilities, but it's not radically different.
You mentioned pumping lots of data down.
Uh-huh.
And so what happens if the client or receiver gets overrun? Does it queue automatically, or do you just?
It'll queue for a bit, and then it starts timing out. They will eventually start doing a timeout if you overrun the client. You got to work really hard to do it, but you can.
What if the client locks up?
Right.
Trying to send it a signal.
You will eventually start getting timeouts,
Okay, and so eventually it will just ignore it and the
and
client
it will
never
disconnect
get
the client.
I mean, does the sender assume the message received, or every message gets something back that says, I got it?
I don't think that there is an ACK response baked into Signal R.
So it's just gonna get lost if I'm the sender.
Yeah,
So
I would
send.
think so. I haven't looked at, I haven't checked that so much myself,
So
but that's
you-
what I would think would happen.
So your
But
use,
you will eventually get a disconnect and timeouts.
so your use cases aren't mission critical or life critical type things.
I would think that if something happened and you noticed that something was failing on the other side, I would think they would you just notice
If
it
that's
failed.
critical, then build some kind of logging or something
Yeah.
on the server side, so that.
On the server side, it'll probably like throw an exception saying, hey, this didn't go through.
Well,
Yeah.
and if it's that critical, I mean, you can build an acknowledgement into the system.
Right.
I may be looking for trouble.
Yeah, that's why I asked about a monitor too, to check for all the
Right.
service.
What's that?
That's why I mentioned about a monitor too, to check for the service up and
Yeah.
down.
I mean, if you had a breakpoint, like you had a breakpoint earlier in the service, in the hub,
Yeah.
when it was running, it wouldn't hit the breakpoint. And say, oh, something happened. Or if it hit the breakpoint and it failed, it would still throw it
But we need another external system to notify us something wrong with the server, if it's a critical application.
So write
Yeah.
something that.
You have to log it. You have to log it or something like that, or just like.
Right.
We log to
Or send a message over a different Signal R hub.
Or send it, have an error hub that sends it back to the thing, say, hey, your stuff's broken.
That's true.
Have a hub for my hub.
Yeah. A hub of hubs.
Hub of hubs.
Hubba. All right, any other questions?
Hit my hub.
Since you talk so much about my app, do you want to see it in action?
Hey Jason, I have a short question.
Next
about
meeting.
the,
Sure.
The area of use of the CPR other than like real-time monitoring, stock trading or something,
Right.
with the perspective of doing the like message notification using like MSNQ or any kind of.
So there's some differences with MSNQ, and they actually kind of leverage into what we were just talking about, right? MSNQ is durable, it's retriable, that kind of stuff. Signal R isn't inherently, right?
MSNQ you can declare like non-durable as well, right?
Yes, you can, but it's also still guaranteed delivery too. Even if it's not durable, you will still have guaranteed delivery. I mean, you've got all kinds of stuff in MSNQ. But
And
MSNQ
also it
is not
on WebSocket rather than
No, MSNQ is not on WebSocket, right? It's not firewall friendly, and it won't scale quite as high as Signal R will.
So
Right.
if I do a DDD approach for the problem or for the project, instead of using messaging queue, MS queue, something like that, or clouds messaging queue, I can use
You could use Signal R, yes. You would have
You
to,
mentioned that it's work with the Azure service.
yes, we will work with Azure Service Bus. So if you have an Azure Service Bus to do your messaging, right, you can have Signal R pulling from that message bus and distributing out to clients,
So that's my focus.
right? And that kind of gives you your cake and eating it too, right? Because you get all the services of the message bus, right? But that's not like Signal R by itself, right? It's just, it's Signal R plus message bus, and then they have integration points that they did
It's just tied.
to make that a
That's where it has that
better.
IP that you're talking,
Yeah.
internet.
But
Right.
message do
You've got
like,
dynamic IP and
Infrastructure would be like it depend on the.
It would depend on the infrastructure, whether you need it, what your requirements are, right?
right.
What the cost requirements are, right? Because there's a cost associated with message bus. There's a whole bunch of things that you can go down to say, yes, message bus is the right choice. Message bus may be overkill. Message bus would be awesome, but the client's not going to pay for it. Because that happens too, right?
But with a message queue though, it's
Well, message queue and message bus are different beasties.
Okay, all right.
Right, but yes, he was talking about message queue as well, so we got message everywhere.
But yeah, message queue though, don't you have like a, you have to get disconnect from the client, they come back on, they'll catch the message again later on, right?
Yeah,
But
guaranteed.
with it's Signal R, if you disconnect from the client,
You don't have guaranteed
you
delivery.
lose it, it's gone.
Yeah, it's
Right.
very high.
Yeah, so you have to have a guaranteed connection in order for that thing to work, because like, you know, well, if you're always connected, then hey, you know, I'd say go Signal R, but if you're not, then,
Well, you see, the thing is, things like MSMQ, because of the durability,
yeah.
right? So there are certain cases where MSMQ is going to be a better choice, or possibly even MSMQ plus Signal R,
Right.
right? Because you can use MSMQ for your guaranteed messaging and that kind of stuff, and then Signal R to actually deliver it down to the end client, right? So I mean, there's a bunch of ways that you can build all of these different pieces together, right? This is another tool that we have in our arsenal, right?
Some
To solve a
process.
very particular problem.
Some process need to be using a durable queue or not to.
And there absolutely are processes that absolutely need to have durable queue. Bank transactions, right?
Yeah.
Right? So I was talking about, stock tickers and that kind of stuff. The actual settlements and the actual trade itself would have to go through a durable queue, right? But getting that trade notification out to the traders' desktops, that doesn't have the same level of durability requirements, right? So, different levels of durability requirements and different technologies that we can bring into play, right? Because if you're doing stock transactions, you don't want to use MSMQ to distribute it out to 10,000 trader desktops, right? Microsoft did try to push that and like multicast MSMQ and other kinds of BS that they had going on, and it didn't fly, and for good reason, right? So Signal R is good for that part of it, but for other parts, MSMQ and the durability and guaranteed delivery, yada transactions, blah, blah, I mean, all the stuff that's in MSMQ may be required, right? So it's not, don't look at it as Signal R for everything, right? Signal R for where it makes sense, and there's a lot of places where it makes sense, right?
Man, it's real time stuff, those.
Yeah, and like the app that I'm working on now, which has like workflow and that kind of stuff, right? Does that need to be durable? No. If it doesn't get to the client, who cares? I mean, seriously, right? I mean, nothing's going to blow up if it doesn't get to the client, right? But it's one of those nice to have. We were talking about it today, right? And our BA was like, oh my God, they would pee themselves if they had that. Isn't that what he said?
Yep, but we're not gonna tell them about it.
We'll be talking about it at our stand-up tomorrow, and it will be in Sprint 5, and it's on your plate. So actually, in our app, we could, what we could do is we could actually tie it into our mail service, like where we're sending out mail notifications, and at the same time that we send the mail notification, send the Signal R notification. And so it would actually just kind of bolt right into the existing code, right? And then we put a little bit of JavaScript in the comment for each page to pop up a little toast, and we'd be done. We could do it in a week,
I was just
If
thinking
that.
that because I've done applications like this, and we've always sent mail. And one of the reasons to send mail is that we have
Client
we have,
notification.
we have a log that says you got it. And especially when you're working with spec changes and things
Right,
like
and-
that. I mean, it's
Well, and this isn't
Especially-
saying this isn't saying that it's replacing the mail, right?
no, you're augmenting.
I'm augmenting.
No, that's
That's
a
right.
nice thing. That's a nice thing.
Right.
For some, and I'm trying to think how I would do it in plant
Yeah.
design, and I've done a lot of plant design, and I'm kind of going,
You actually only have a log that it was sent.
well, that's true.
But technically, yes.
That's
Can-
true,
can you
but I
force
do
a
have a log that
response?
says it was sent.
Can you respond, force an open?
And we have a
message?
particular team member that, never receives them. We all know those, right?
The thing
Get that
is,
message.
Is this time to
you
use
do,
a
I mean,
single
that's part of the
pixel?
that's part of the management thing is that you know your clients and you
Uh-huh.
check up on, you do back checks on.
Right.
Or use console?
All right, folks.
Or you ask them to get back to you or.
Thank you for joining us for the January 2018 meeting of the Houston.net Users Group. If you happen to be in Houston on the second Thursday of any month, you're welcome to join us at Improving Houston, located at 10111 Richmond Avenue, just inside the Beltway in the West Chase area of Houston. Hope to see you there soon.